In this video, I'm going to show you what I mean by a system of forces making a couple. So here I have a uniform plank, and I have of 5 meters long, and then I have a force acting up here at 8 newtons. And then 1 meter away, I have an opposite force of 3 newtons, and then 5 meters away, I have a opposite force of 5 newtons. Now, if I resolve these forces parallel to the 8 newton, I say parallel rather than vertically or horizontally because this plank could be at this angle or it could be vertical. If I resolve them parallel to one of the forces, then 8 minus 3 newtons minus 5 newtons gives 0. That means there's no translationary movement. That means there's no movement this way, or if it was at this angle, there'd be no movement this way, or if it was vertical, there'd be no movement this way. However, there is a rotational movement, and we can see that by just taking moments. So if I put my point P here, and you can move the point P, there's about 4 different cases, and then this force here will be going anti-clockwise, and anti-clock moments are positive, so it's 8 times 3, and then going clockwise, so it's negative, so it's going to be 3 times this distance here, which is 4, and then minus also 5 times this distance here, which is 8, which gives an overall moment of minus 20 newton meters, 28 newton meters. Minus means that overall it will move clockwise. So if we look at the conclusion here, a system of forces forms a couple. A couple has a turning effect but cannot produce a translationary effect. The turning effect in this case will always be 28 newton meters clockwise. Now if I move P to somewhere else, so just move the x coordinate first of all. Okay, we can still see it is minus 28. Okay, so now it's going to become minus, this now will actually go clockwise, and these two will go clockwise as well. We're going to get minus 8 times 0.5, minus 3 times 0.5, and then minus 5 times 4.5. If I then move it, I can have it actually on a point, okay, still going to get minus 28, and then if I move it in here, okay, so this now, if that's now the point, okay, this one will be clockwise. Okay, this one will be anti-clockwise, that's why it's 3 times 1.5, and this one will be clockwise, so it's 5 times minus 2.5. Okay, and then I can also move it out over here as well. Okay, in this case, these two here will be anti-clockwise, and this one will be clockwise. Okay, but we're always going to get a total moment of minus 28 newton meters, which means 28 newton meters clockwise. Okay, so a couple will have a turning effect, but there'll be no translationary effect. So perhaps in real life, maybe if you're taking off a well with a spanner where you have to sort of rotate it round, one which has like those either side, then you can see the idea of a couple. We can also move the y coordinate as well. It has no real effect. Okay, we can move these around. Okay, and we can actually put y actually onto the bar if we wanted to. It doesn't really matter. Okay, the other interesting thing here is that you can also see that the moment will always be perpendicular to the line, the distance in the line of action of the force. So you just have to extend this line down here like that, and then this line, even though it's going to go this way, just extend the line down, you can still get the moment. I hope you've understood, and I thank you very much for watching.